Have you ever looked at the world and wondered how we find patterns in what seems like total chaos? Or how we can possibly know if two things are connected? Well, today we're going to dive into the statistical tools that let us see those hidden relationships. And we're going to start with a deceptively simple puzzle. Okay, so picture this. You've got a drinks machine, right? It pours a random amount of lemonade into a cup that's also a random size. What are the odds you're about to have a sticky mess on your hands? Answering a question with two random things going on is tricky. To even get close, we first have to figure out how to handle just one. So before we can tackle both the lemonade and the cup, we've got to get a handle on just one of them. And for that, statisticians have this incredible method called transformations. It's really the bedrock for understanding how a single random thing changes when you change the rules of the game. Think of this four-step method as a kind of recipe for understanding a single random variable. It's a super useful tool, for sure. But you know, the real magic, the really interesting stuff, happens when we bring a second character into our story. That's when we can truly start hunting for relationships. All right, we've got the basics down for one variable. Now let's level up and throw a second one into the mix. This is where we can start asking, are these two things related? So we'll leave the lemonade stand for a bit and turn to this. Let's call it a more adult example from our source material, the daily tipple. Now, this table, it's officially called a joint probability mass function, but really, just think of it as a map of all the possibilities. Each little box tells you the chance of two things happening at the same time. So for instance, what's the probability that someone has exactly 2 beers, that's our X, and 1 whiskey, that's our Y? Well, you just find where they meet, and boom, 0.45, or a 45% chance. Okay, but watch this. This is where it gets cool. If you add up all the numbers in a row, you get the total probability for just the whiskey, completely ignoring the beer. And if you add up a column, you get the total probability for just the beer. They call these marginal distributions. And it's a great name because you're literally writing the totals in the margins of the table. So we've got our two variables hanging out in the same table. We know their chances of happening together, and we know their chances of happening alone. But here's the million-dollar question. Are they actually connected? Are they influencing each other? To figure that out, we need to go beyond just looking and get a hard number. Our first tool for the job is something called covariance. It's basically a quick and dirty signal. If the number's positive, it means the variables tend to move together. If it's negative, they move in opposite directions. It's like asking, are you guys on the same team or are you rivals? But knowing if they're teammates or rivals is only half the story, right? What we really want to know is how strong is that relationship? Are they best friends or just casual acquaintances? For that, we need correlation. It takes that raw signal from covariance and puts it on this beautiful, easy-to-read scale that always goes from -1 to +1. And this slide just nails the difference. Covariance can be any old number, like 5 or -200 or 0.03, which makes it really hard to judge. But correlation, it's standardized. A correlation of positive 0.8 is always a strong positive linear link, no matter if you're talking about drinks or planets. It just gives you the whole story, direction and strength. So let's put it to the test. For our beer and whiskey example, the source material walks us through the math of finding the covariance and the variance for each drink. And when you put all those numbers into the correlation formula, you get this, plus 0.218. Okay, so what in the world does that number actually mean? Well, let's break it down. The plus sign tells us they tend to move in the same direction. More beer tends to go with more whiskey. But 0.218 is pretty darned close to 0. And that tells us that this connection, this linear relationship, is actually quite weak. So we've seen a weak relationship. But what if there's no relationship at all? Well, this question leads us straight into a really fascinating and honestly a very common statistical trap. It's an illusion that can fool you if you're not careful. First, let's lay down a solid fact. The math here is crystal clear. If two things are truly, completely independent, meaning one has 0 effect on the other, then their correlation will always be 0. Period. No debate. But, and this is the big but, what about the other way around? This is the trap. If you run the numbers and you get a big fat 0 for your correlation, can you just pack up your bags and say, welp, guess these two have nothing to do with each other? I want you to look at this clever example. If you crunch the numbers for this data, the covariance and correlation come out to exactly 0. But just look at it. The table shows that if x is 0, y cannot be 1. The value of one variable is clearly affecting the other, so they are absolutely dependent, even with a correlation of 0. And that brings us to maybe one of the most important lessons in all of statistics. Say it with me. Zero correlation does not mean they're independent. All it means is that there's no straight line relationship. You could have a perfect U-shaped relationship connecting two variables, and the correlation could still be 0. It's a huge distinction. So, after all that, why should you care? Because these ideas, joint probabilities, correlation, and especially that subtle difference between uncorrelated and independent, they aren't just for textbooks. They are how we make sense of our incredibly complex world. They let us see the connections hiding in plain sight. I mean, these tools are used absolutely everywhere. Public health experts use them to understand the link between height and weight. Economists use them to see how a degree might connect to a starting salary. And yeah, as our source material jokingly points out, you can even use them to figure out if there's a relationship between the buns and donuts some guy named Bob buys from a cake shop. So there you have it. We started with a simple question about spilling lemonade and ended up with the keys to unlocking some of the hidden rules of the universe, which really just leaves one final question. Now that you know how to look, what unseen connections, what hidden relationships might you find shaping your world?